In the first example, we will factor 2x squared plus 7x plus 6. To make it easier to follow along, I will write the steps on the left-hand side and the expression in each step on the right-hand side as we go through them. Step 1. Find the product, sum, and two numbers that work. To find the product, we multiply our first number by our last number. In this case, that's 2 times positive 6 for a product of positive 12. Our sum is always the middle number, in this case, positive 7. The next part is to find two numbers that work. This means finding two numbers whose product or that multiply to give us positive 12 and whose sum or which add to give us positive 7. In this case, those numbers are positive 4 and positive 3, simply because positive 4 times positive 3 is positive 12, and positive 4 plus positive 3 is positive 7. The second step is to split the middle term, which means now we have to focus on the variable as well as the number. So in place of 7x, we will now replace it using the two numbers we just found, positive 4 and positive 3. The first term, 2x squared, and the last term, positive 6, stay as they are. And in the middle, we now write positive 4x plus 3x, which if you check, adds to give you positive 7x. We do this, though, so that when we try to do step 3, we're able to group them in groups of 2 and factor out the greatest common factor in each group. In our first group, we should see that we have a greatest common factor of 2x. Factoring out 2x leaves us x plus 2, and then we repeat the same process in the next group. In this group, we have a GCF of positive 3, and once again, when we factor out positive 3, we're left with x plus 2. It's important to note that x plus 2, or whatever the equation is, must be the same on both sides. If not, you've made a mistake either in the factoring out the GCF or in identifying the two numbers that filled the product and sum in step 1. Our final answer is to write our equation in factored form. Looking at the colors, in the yellow highlighted factor, once again the common factor in both terms, becomes one of our factors, and our second expression is a result of the GCFs we factored out, or 2x plus 3. Let's try a second example, this time involving negatives. Once again, step 1, we need to find the product, sum, and two numbers that work. Our product, first number times last number, 10 times negative 3, gives us a product of negative 30. Our sum is our middle number, or negative 1. Careful, a lot of times we forget there's a number in front when there's only a variable given, but remember it is negative 1. And finally, we need to find two numbers that work. It's a little trickier when working with negatives, so pay close attention to the signs as you're multiplying. In this case, the two numbers that work are positive 5 and negative 6, because when we multiply them, we get negative 30, and when we add them, it equals negative 1. Step 2, split the middle term. Once again, the negative a is going to be split using our positive 5 and negative 6. 10a squared in front remains the same. Negative 3 at the end remains the same. In place of negative a, we write positive 5a and negative 6a. In the previous example, we used the variable x. This time we're using the variable a. It doesn't make any difference. The same methods, the same rules apply, regardless of the variable used. Step 3, group our four terms into groups of 2 and factor out the GCF of each group. In our first group, we can see our greatest common factor is 5a, and when we take out 5a, we're left with 2a plus 1. Remember, when you divide 5a by itself, the term does not disappear. We're left with plus 1. In our second group, the GCF is negative 3, and dividing out negative 3 leaves us 2a plus 1. And we can see we have the same expression in both parts. Our final answer is to write our equation in factored form, giving us 2a plus 1 and 5a minus 3. This completes your lesson.